Question 1. What is the value of pi to the power of 10 to two significant figures? Typing in pi to the power of 10, this is the result. This will need to be rounded to two significant figures and expressed in scientific notation. The calculator has a mode that can do both. If you press Shift, Mode, and number 7, SCI, then pressing 2 for two significant figures, the calculator will then express the answer in the correct format to the correct number of significant figures. So in this case, it's 9.4 times 10 to the power of 4. So the answer is option B. To get the calculator back out of scientific notation mode, press Shift, Mode, number 8, Norm, and then number 2. And it's back to non-scientific notation mode. Question 2. What values of x satisfy 4 minus 3x is less than or equal to 12? We want the term involving x to be positive, so we can rearrange the inequality by adding 3x to both sides of the inequality. So our first line could be 4 is less than or equal to 12 plus 3x. Then subtracting 12 from both sides of the inequality, we have negative 8 is less than or equal to 3x. Finally, dividing both sides of the inequality by 3, we get negative 8 over 3 is less than or equal to x, which means that x is greater than or equal to negative 8 over 3. Therefore, the answer is option D. Question 3. What is the value of p so that a to the power of 2 times a to the power of negative 3 over the square root of a equals a to the power of p? Rewriting the left-hand side of the equation so that index laws can be applied, the numerator is a squared multiplied by a to the power of negative 3, and then it's divided by the square root of a. So that's the square root of a to the power of half, expressing the surd in index form. Now applying the index laws, multiplying two terms with the same base, we add the indices. So that'll be a to the power of negative 1 divided by a to the power of half. And dividing two terms with the same base, we subtract the indices. So that's equal to a to the power of negative 1 minus half, which is equal to a to the power of negative 3 over 2. Therefore, p is equal to negative 3 over 2, since we can equate the indices on both sides. So the answer is option B. Question 5. Which of the following is equal to log base 2 of 9 over log base 2 of 3? This expression is based on the change of base rule, and we can express this quotient of two logarithms with the same base as a single logarithm, which will be log base 3 of 9. So now we need to think about what index we raised 3 by to get 9, and clearly 3 squared equals 9, since 3 to the power of 2 is equal to 9. Therefore, the answer is option A. Question 6. A game is played by tossing an ordinary 6-sided die and an ordinary coin at the same time. The game is won if the uppermost face of the die shows an even number or the uppermost face of the coin shows a tail, or both. What is the probability of winning this game? Complements may be used to determine the probability of a win. So we have the probability of a win is equal to 1 minus the probability of a loss, or probability of losing, and that's equal to 1 minus the probability of throwing an odd number, which is half, multiplied by the probability of showing heads on the coin. So that's also half, which is equal to 1 minus 1/4, which is equal to 3 over 4. Therefore, the answer is option C. Question 7. The diagram shows part of the graph of y equals a sine bx plus 4. What are the values of a and b? A represents the amplitude of the sine curve, which is the vertical distance from the line of centre to either the peak or the trough. Now in this case, the line of centre is y equals 4, and that comes from this part of the function here. And the distance from the line of centre to the peak, or the trough in this case, 4 to 5.5 is 1.5. So A equals 1.5. Now the period of this sine curve is pi radians. So that's the horizontal distance for the sine curve to complete one full cycle. And the period equals 2 pi over b. So if the period is pi radians, we can calculate the value of b by rearranging this formula. We have b is equal to 2 pi over pi. Therefore b is equal to 2. Hence the answer is option D. A is equal to 1.5 and b is equal to 2. Question 8. A particle is moving along a straight line. The graph shows the acceleration of the particle. For what values of t is the velocity v a maximum? Looking at the graph of acceleration with respect to time, we can see that the graph is above the x-axis between t equals 0 and t equals 3 and below the x-axis between t equals 3 and t equals 5. Now acceleration represents the rate of change of velocity with respect to time. So if the acceleration is positive, that means that the rate of change of velocity with respect to time is positive, which implies the velocity is increasing. And vice versa for this part of the graph here. Negative acceleration implies a negative rate of change of velocity with respect to time, which means the particle is decreasing in velocity. Now at t equals 3, the particle is neither increasing nor decreasing in velocity. So it is in fact a stationary point. And it's a maximum stationary point because to the left of that stationary point, the rate of change of velocity with respect to time is positive, indicated by the part of the graph that's above the x-axis. And to the right of t equals 3, the rate of change of velocity with respect to time is negative, which implies then that t equals 3 represents a local maximum stationary point. Hence, the value of t, where the velocity v is a maximum, occurs at t equals 3. Therefore, the answer is option C. Question 9. Which expression is equal to the integral of tan squared x dx? To integrate tan squared x with respect to x, we will need to change the form of the integrand into something more recognizable. Using a Pythagorean identity, we know that sine squared x plus cos squared x equals 1. Dividing all three terms by cos squared x, we have tan squared x plus 1 is equal to sec squared x. And we can certainly integrate sec squared x since the derivative of tan x is sec squared x, hence the antiderivative of sec squared x is tan x. So rearranging this equation to make tan squared x the subject of the formula, we have tan squared x is equal to sec squared x minus 1. Now integrating all the terms of the equation with respect to x, the integral of tan squared x with respect to x is equal to the integral of sec squared x minus 1 with respect to x. And that is equal to tan x minus x plus the constant c. Hence the answer is option A. Question 10. A particle is moving along a straight line with displacement x at time t. The particle is stationary when t equals 11 and when t equals 13. Which of the following must be true in this case? It is given that the particle is stationary when t equals 11 and t equals 13. That means the velocity of the particle equals 0 when t equals 11 and t equals 13. The following is a graph of the velocity of the particle with respect to time, and it can be seen that where the graph intersects with the x-axis, they are the points where the velocity of the particle equals 0. Now the rate of change of velocity with respect to time is negative on this side, but positive on this side. So there must be a stationary point between t equals 11 and t equals 13. And the rate of change of velocity with respect to time is in fact the acceleration of the particle. So there must be a point between t equals 11 and t equals 13 where the acceleration is equal to 0. Therefore, the answer is option C. Question 1. Which of the following shapes has a perimeter of 12 centimeters? Now, perimeter is the distance around the outside of the shape. So if you take, for example, option B, 4 plus 3 is 7, 7 plus 2 is 9, can't be B. You're probably saying, no, it's A. Of course it's A. A rectangle has opposite sides equal. So if that's 2 centimeters there, so this is the height of the rectangle. This one here is 2 centimeters as well. Opposite sides are equal and parallel, of course, in a rectangle. 4 centimeters for the length down here. This one's also 4. 2 plus 4 is 6. 6 plus 2 is 8. 8 plus 4 is 12 centimeters. So the answer is A. Question 3. Chris opens a bank account and deposits $1,000 into it. Interest is paid at 3.5% per annum, compounding annually. Assuming no further deposits or withdrawals are made, what will be the balance in the account at the end of 2 years? Okay, so this is just a standard or a regular compound interest, present value to future value scenario. So, future value is equal to the present value multiplied by 1 plus the interest rate as a percentage per period to the power of n, which is the number of compounding periods. So the present value is $1,000. 1 plus the interest rate, which is 3.5% per annum, which means per year. So I'm just going to write it as a percentage. Compounding annually, so that's important to know. Okay, so each compounding period is 1 year, and the number of compounding periods is 2 because it's at the end of 2 years. So it's going to be to the power of 2. Okay, so entering in this expression to the calculator, 1 plus 3.5% to the power of 2, and we get $1,071.23. Okay, so that's going to be option B. Question 4. Which compass bearing is the same as a true bearing of 110 degrees? What we'll do first is we'll draw a quick compass rose. There's north, okay, that's 0, 0, 0 degrees using 3-figure bearings. 110 degrees, okay, that's just south of east, isn't it? So that's 0, 9, 0. There's south, which is 180 degrees. 110 would be somewhere there, okay? So there's 110 degrees. So that's going to be south 70 degrees to the east, because from south measuring back towards east, we need to go back 70 degrees. Okay, so this bearing here is south 70 degrees to the east. And so the answer is C. Question 7. Julia earns $28 per hour. Her hourly pay rate increases by 2%. How much will she earn for a 4-hour shift with this increase? So let's see how much she earns currently. $28 per hour. She works for 4 hours, but her pay is going to increase by 2%. And the way we implement an increase in mathematics is to multiply by 102%. Okay. So $28 an hour times 4 hours times 102%. We get $114.24. Option D. Question 9. What is the interest earned in dollars if $800 is invested for X months at a simple interest rate of 3% per annum? Simple interest means we're going to use the formula I equals P times R times N. Now, the P, the principal, is $800. The interest rate is 3%. Okay. Now, the time, the N, is X months. But the interest rate is per annum per year, which means that we have to divide the X by 12. So I'm going to multiply this by 1 on 12 times X months. So this converts X months into years, or converts it into the time unit of years. Now, multiplying all this together, okay, so, 800 multiplied by 3%, multiplied by 1 on 12, times X, and we get 2. So the answer is 2X. Option A. Question 10. A school collected data related to the reasons given by students for arriving late. The Pareto chart shows the data collected. The way we're going to answer this question is we're going to use the cumulative frequency polygon. We're going to look at train or bus delay. Now, at this point here, this is 92%. But because it's cumulative, this includes all the other reasons in front of it as well. So this includes sleeping in, family, and appointment. So we can't include these 3 columns. This point here is 86%. And this 86% refers to appointment, family, and sleeping in combined. So 92% minus 86% will give you the percentage contributed by just train or bus delay alone, and that'll be 6%, which is option A. Now, the other way you could do this is to add up all the columns individually, get a total, and then divide train or bus delay by the sum of all these columns, but that'll take you a lot longer. It's much quicker to use the cumulative frequency polygon and just understand it is cumulative, which means that if you take a point and subtract the point before it, that'll give you the percentage contributed for that particular reason. Question 11. Which of the following correctly expresses y as the subject of the formula 3x minus 4y minus 1 equals 0? So what we're going to do, we're going to leave the negative 4y alone. Okay. We're going to move the 3x over, so it becomes negative 3x. And we're going to move the negative 1 over to the other side, it becomes positive 1. Next thing we're going to do is we're going to divide by negative 1. So 4y is equal to 3x minus 1. Okay, so by dividing by negative 1 or multiplying by negative 1, it switches the signs of all the terms on the other side. And then lastly, we're going to divide everything by 4. So 3x minus 1 over 4. And that'll be option C. Question 12. An owl is 7 meters above ground level in a tree. The owl sees a mouse on the ground at an angle of depression of 32 degrees. How far must the owl fly in a straight line to catch the mouse, assuming the mouse does not move? First thing we do, let's draw a wireframe sketch. There's our tree, there's the ground, here's the straight line distance, there's the mouse, okay. There's the owl, 90-degree angle. Now we'll draw in our angle of depression, which is drawn reference to a horizontal. Now the angle of depression and the angle of elevation are in fact identical, and from the owl, from the top of the tree to the ground is 7 meters, and we want to find the straight line distance. According to Sohcahtoa, this is going to be sine because it's opposite over hypotenuse. So sine 32 degrees is equal to 7 over x. X is equal to, you can just move the 7 on top of the sine 32. and then just enter that into your calculator. I'll just do that now. 7 over sine 32 degrees. And we get 13.2, which is option D. Question 13. The graphs show the future values over time of P dollars invested at 3 different rates of compound interest. Which of the following correctly identifies each graph? Let's have a look at the graphs carefully. Curve W and curve X are fairly close to each other. We would expect that the compound interest rate for W and X to be fairly close. Y should be quite a lot lower. Look at option A and option B. Option A shows W with 5% interest versus X at 10% interest and Y at 10% interest. W should be the highest, so it's not option A. Option B also shows W at 5% interest and Y at 10% interest, and that doesn't make sense. So can't be option B. W should be the higher rate of interest. Option C and option D shows the interest rates identical in fact. In fact, they almost look the same, like the same option. The only difference is that W in option C, W is being compounded quarterly, X is being compounded annually. The more often something is compounded, given the same principle and the same interest rate per annum, the more often the compounding, the higher the future value. This is compounded quarterly. This X is compounded annually. Whereby in option D, W is compounded annually, X is compounded quarterly, so this would imply that X should be higher than W, so it can't be D. The answer is option C. Question 14. Last Saturday, Luke had 165 followers on social media. Reese had 537 followers. On average, Luke gains another 3 followers per day, and Reese loses 2 followers per day. If X represents the number of days since last Saturday, and Y represents the number of followers, which pair of equations model this situation? Now, the numbers 165 and 537 represent a y-intercept. So I would expect the y-intercept for Luke should be 165. So clearly option B could be 1, but not option A. Nor option D for that matter. The y-intercept here is 3. So we've got a choice between B and C. Now, let's have a look at the number of followers per day, or the gain or loss, the number of followers. Luke gains 3 followers per day. So I would expect a gradient of 3 for Luke. Reese loses 2 followers per day. I would expect a gradient of -2 for Reese. Now, X is the number of days that passes. So for every day that passes, Luke is gaining 3 followers per day. Reese is losing 2 followers per day. So I expect to have an equation that models Luke's gains to have a 3x in it. Here it is. Also expect an equation that models Reese's losses to be -2x. And here it is. So the answer is option B. Question 15. The scores on an examination are normally distributed with a mean of 70 and a standard deviation of 6. Michael received a score on the examination between the lower quartile and the upper quartile of the scores. Which shaded region most accurately represents where Michael's score lies? Now, first thing to note is the standard deviation of 6 and the mean of 70. Plus or minus 1 standard deviation is 68% of the scores. Michael received a score, however, between the lower quartile and the upper quartile of scores. So this is the middle, or this represents the middle 50% of scores. So, for example, let's have a look at option A. Between 64 and 76 is 68% of the scores. But Michael achieved a mark in the middle 50%, which should be inside 64. So it should be greater than 64, but less than 76. So it looks like option A is in fact the correct answer. Just while we have some time, let's have a look at option B. Option B is incorrect because from 64 to 76, this is 68. Again, 68% of the scores lie between here and here. Option C, this is beyond plus or minus 1 standard deviation. In fact, this is greater than 68% of the scores, because we've actually gone beyond plus or minus 1 standard deviation. All right? If you were to draw a box and whisker plot, going from Q1 to Q3, lower quartile to upper quartile, has 50% of the scores. Again, should be inside 64 and 76. And clearly D is totally incorrect. That's just above a mean of 70. So that makes no sense at all. Question 1. What is the domain of the function f of x equals ln of 4 minus x? The natural domain of the base function y equals ln of u is u's greater than 0. To find the domain of f of x equals ln of 4 minus x, we need to solve the inequality u greater than 0 where u is equal to 4 minus x. So we need to solve the inequality 4 minus x greater than 0. Starting with 4 minus x greater than 0, add x to both sides of the inequality to make x positive. So we have 4 minus x plus x is greater than 0 plus x, which simplifies to 4 greater than x, which means that x is less than 4. Hence, the answer is option A. Question 4. The diagram shows the graph of y equals f of x. Which equation best describes the graph? The graph of y equals f of x has vertical asymptotes at x equals -1 and x equals 1, and a horizontal asymptote at y equals 1. Now, all four options have the same vertical asymptotes, but a different horizontal asymptote. By inspection, option B looks most likely to be correct. So let's check this. The horizontal asymptote is given by the limit as x approaches infinity of x squared over x squared minus 1. Divide each term by the term in x that has the highest power, which is x squared. So dividing each of these three terms by x squared, we have the limit as x approaches infinity of x squared over x squared, that's the numerator, over x squared over x squared minus 1 over x squared. Simplifying the numerator and the denominator, that equals the limit as x approaches infinity of 1 over 1 minus 1 over x squared. Applying the limit, 1 over x squared, so 1 over infinity squared, is equal to 0. So that equals 1 over 1 minus 0, which equals 1. Therefore, the answer is option B. Question 11a. Using the sine rule, find the value of x correct to 1 decimal place. Equating the side angle pairs, we have x over sine 40 degrees equals 8 over sine 110 degrees. Rearranging the equation to make x the subject of the formula, we have x equals 8 times sine 40 degrees over sine 110 degrees. Making sure your calculator is in degrees and not radians, that equals 5.472 and so on, and that rounds to 5.5 correct to 1 decimal place. Question 11b. Differentiate x squared sine x. The product rule is applied because we are differentiating a product of two functions, which is x squared multiplied by sine x. By the product rule, y dash is equal to u dash v plus uv dash, where u is equal to x squared, u dash is equal to 2x, v is equal to sine x, and v dash is equal to cos x. Therefore, y dash is equal to 2x sine x plus x squared cos x. Question 11c. Differentiate 2x plus 1 over x plus 5. We are dealing with the first derivative of a quotient of two functions in x. Hence, we use the quotient rule. So by the quotient rule, y dash is equal to u dash v minus uv dash over v squared, where u is equal to 2x plus 1, u dash is equal to 2, v is equal to x plus 5, and v dash is equal to 1. Hence, y dash is equal to 2 outside of x plus 5 minus 2x plus 1 in brackets over x plus 5 all squared, which equals 2x plus 10 minus 2x minus 1, so that's after expansion of the brackets, and simplifying the numerator, we have y dash, or the first derivative, is equal to 9 over x plus 5 all squared. Question 11D. What is the limiting sum of the following geometric series? 2000 minus 1200 plus 720 minus 432, and so on. The first term of this geometric series is 2000, and the common ratio can be found by taking one term and dividing it by the term immediately before it. So negative 1200 is t2 divided by t1, the term immediately before it, and that equals negative 3 over 5. Now the sum to infinity of a geometric progression is equal to a divided by 1 minus r, and that equals 2000 divided by 1 minus negative 3 over 5, and of course minus minus makes a plus, and that evaluates to 1250. Question 11e. Evaluate the definite integral from x equals 0 to x equals 1 of 1 over 3x plus 2 all squared dx. The first step is to rewrite the integrand with a negative index. So 1 over 3x plus 2 all squared can be written as 3x plus 2 to the power of negative 2. So integrating this expression, we get 3x plus 2 to the power of negative 1. So we add 1 to the index, then divide by the new index. So we divide by negative 1, but then we divide by the derivative of what's inside the bracket. So we're going to divide by 3. So that's the reverse of the chain rule. And that equals negative 1 over 3 multiplied by 1 over 3x plus 2 from x equals 0 to x equals 1. Then applying the limits of integration, that equals negative 1 over 3 multiplied by 1 over 5 minus 1 over 2, and that equals 1 over 10. Question 11F. A bag contains 5 green beads and 7 purple beads. 2 beads are selected at random without replacement. What is the probability that the 2 beads are the same color? This probability experiment has 4 outcomes: green green, green purple, purple green, or purple purple. Now we want to find the probability that the 2 beads drawn are the same color, so we're interested in green green or purple purple. Now this is selection without replacement. In the first draw, there are 12 beads to choose from, and in the second draw, there are 11 beads to choose from. So the probability of green green or purple purple is equal to 5 over 12, since there are 5 green beads to choose from initially, out of a total of 12. And assuming that the first bead chosen is green, then there are 4 green beads left to choose from 11 beads left. So it's 5 over 12 multiplied by 4 over 11. And the probability of purple purple is 7 over 12, since there are 7 purple beads initially to choose from out of a total of 12, multiplied by 6 purple beads out of a total of 11 in the second draw. So 5 over 12 multiplied by 4 over 11 plus 7 over 12 multiplied by 6 over 11 is equal to 31 over 66. Question 12a. The line L with equation x minus 2y plus 4 equals 0 passes through the point A, 8, 6, and intersects the x-axis at the point B. The line through A perpendicular to L intersects the x-axis at the point C. Part 1. Find the equation of the line AC. The first thing we need to work out is the gradient of line L, and we can do that by converting the equation of line L in general form into the form y equals mx plus c, or gradient intercept form. So rearranging this equation, I'm going to make y the subject. We have 2y's equal to x plus 4. Dividing everything by 2, we get y is equal to x over 2 plus 2. So the gradient of L is half. Hence, the gradient of AC is the negative reciprocal of the gradient of L, since line L is perpendicular to line AC. So the gradient of line AC is equal to -1 divided by half, which equals -2. Now the line AC also passes through the point 8, 6. So using the point gradient formula, we can determine the equation of line AC. So y minus y1, so that's y minus 6, is equal to -2 times x minus x1, or x minus 8. Expanding the brackets, we have y minus 6 is equal to -2x plus 16. And adding 6 to both sides of the equation, we have y is equal to -2x plus 22. Part 2. Find the area of triangle ABC. The perpendicular height of triangle ABC is 6 units, and it's shown on this diagram here. So the next thing we need to determine is the length of the base of triangle ABC, so the length of BC. So we need the x-coordinate of point B and the x-coordinate of point C. Now the equation of AB, or line L, is x minus 2y plus 4 equals 0, and the equation of AC is y equals -2x plus 22, which was found in part 1. So to find the x-coordinates of point B and C, we substitute y equals 0 into both of these equations and then solve for x. So the x-coordinate of point B, so we'll let y equals 0, x minus 2 times 0 plus 4 equals 0, x equals -4, and the x-coordinate of point C, we have 0 equals -2x plus 22. Solving this equation for x, we get x equals 11. Hence, the base of triangle ABC is 15 units. Therefore, the area of triangle ABC is equal to half times the base times the height, so half times 15 times 6, which equals 45 square units. Question 12b. In an arithmetic series, the fourth term is 6 and the sum of the first 16 terms is 120. Find the common difference. The solution is based on solving a pair of simultaneous equations. Now we know that T4 is equal to 6, so the fourth term of the arithmetic progression is equal to 6. We also know that the sum of the first 16 terms of the same progression is equal to 120. So here's the pair of simultaneous equations we are about to solve. Tn is equal to a plus n minus 1d, so that's the formula for the general term of an arithmetic progression. And Sn is equal to n over 2 outside of 2a plus n minus 1d, and that's the formula for the sum of the first n terms of an arithmetic progression. And it's the same arithmetic progression, of course, that we're referring to. Now we know Tn, we know Sn, and we know the value of n that gives us Tn. So T4 is equal to 6, and S of 16, so when n equals 16, S of 16 is equal to 120. So we'll apply that data and substitute those into these two equations and set up the pair of equations that we will solve simultaneously. So from this equation here, we have 6 is equal to a plus 3d, that's n minus 1, so that's 4 minus 1 is equal to 3. And for this equation here, the Sn, the sum of the first n terms, we have 120 equals 8, so that's 16 over 2, 8 outside of 2a plus 15d. So n is equal to 16, 16 minus 1 is 15, multiplied by the common difference d. Now I'm going to solve this pair of simultaneous equations using the elimination method on a. But in order to do that, we have 8 times 2a, which is 16a, so this is in the Sn equation. And I want to eliminate the a, so I need a 16a to appear in the Tn equation. So I'm going to multiply this equation here by 16, so I have a term involving 16a. That way I can just subtract one from the other and the 16a's will disappear. And we end up with these two equations. So I'll call these equations 1 and 2. So using the elimination method now, equation 2 minus equation 1, we get 24 equals 72d. And dividing both sides by 72, we have d is equal to 1 over 3. So therefore, the common difference is 1/3. Question 12c. The number of leaves, L of t, on a tree t days after the start of autumn can be modelled by L of t equals 200,000 e to the power of -0.14t. Part 1. What is the number of leaves on the tree when t equals 31? Substituting t equals 31 into the equation, we have L of 31 equals 200,000 multiplied by e to the power of negative 0.14 multiplied by 31, and that equals 2,607.305 and so on. And rounding that number to the nearest leaf, that equals 2,607 leaves. Part 2. What is the rate of change of the number of leaves on the tree when t equals 31? To find the rate of change, we need the first derivative of L of t. So L dash of t is equal to negative 0.14 multiplied by 200,000 multiplied by e to the power of negative 0.14t. Substituting t equals 31 into L dash of t, we have L dash of 31 equals negative 0.14 times 200,000 times e to the power of negative 0.14 times 31. And that equals negative 365.02 ... leaves per day. Part 3. For what value of t are there 100 leaves on the tree? Solve for t the equation L of t equals 100. Now L of t is equal to 200,000 multiplied by e to the power of negative 0.14t, and that's going to be made to equal 100. We're going to make t the subject of the formula. So we're going to start off by dividing both sides by 200,000. And that gives us e to the power of negative 0.14t equals 1 over 2,000. And since we're dealing with a base e, we can take the natural logarithm of both sides. So that gives us negative 0.14t equals ln of 1 over 2,000. And ln of 1 over 2,000 is negative ln of 2,000. Multiplying both sides by negative 1 and then dividing by 0.14, we have t equals ln of 2,000 divided by 0.14, and that equals 54.292 and so on. Therefore, 100 leaves are left after 54.292 days. Question 12d. The diagram shows the graph of y equals 3x over x squared plus 1. The region enclosed by the graph, the x-axis, and the line x equals 3 is shaded. Calculate the exact value of the area of the shaded region. The following are the marking guidelines for question 12d. For 1 mark, we have obtains correct definite integral or equivalent merit. For 2 marks, we have obtains correct primitive or equivalent merit. And for 3 marks, we have provides correct solution. Since the shaded region is entirely above the x-axis, the definite integral in this case represents the area under the curve. So the area is equal to the definite integral from x equals 0 to x equals 3 of 3x over x squared plus 1 dx. Now the integrand is almost in the form f dash of x over f of x, but we want 2x in the numerator to be truly in the form f dash of x over f of x, which means that the primitive is going to involve a logarithmic function. Now we can change the 3x into 2x by dividing the numerator by 3 over 2, but we need to compensate for that division by 3 over 2 by multiplying the entire integral by 3 over 2 on the outside. So the integrand 3x over x squared plus 1 can be turned into 2x over x squared plus 1, and then multiplying the entire integral by 3 over 2 on the outside. Now it's in the form f dash of x over f of x. So integrating this expression, that equals 3 over 2 multiplied by ln of x squared plus 1, so ln of f of x, from x equals 0 to x equals 3. Applying the limits of integration, that equals 3 over 2 multiplied by ln of 10 minus ln of 1, and ln of 1 of course is 0, and that equals 3 over 2 multiplied by ln of 10 square units. The following is the feedback from the marking center for question 12d. Students should use definite integrals to find areas. In better responses, students were able to find the correct fraction in front of the integral in order to create a numerator, which is the derivative of the denominator. And areas for students to improve include integrating correctly to reach a logarithmic function, substituting limits correctly, showing all working, reading the question carefully, and using brackets accurately. Question 13a. Solve 2 sine x cos x equals sine x for x greater than or equal to 0 and less than or equal to 2 pi. Rearrange the equation such that the right-hand side equals 0. So starting with 2 sine x cos x equals sine x, subtract sine x from both sides of the equation, so we have 2 sine x cos x minus sine x equals 0. The next step is to factorize out sine x on the left-hand side. So taking out sine x from this term and this term, we have sine x multiplied by 2 cos x minus 1 equals 0. Now this gives rise to two cases. Either sine x equals 0 or 2 cos x minus 1 equals 0. So case 1, sine x equals 0, we have x equals 0, pi or 2 pi. And for case 2, we have 2 cos x minus 1 equals 0. Rearranging this equation, we have cos x equals half, which means x equals pi over 3 or 5 pi over 3. Combining all those solutions together, we have the solution is x equals 0, pi over 3, pi, 5 pi over 3, or 2 pi. Question 13b. The diagram shows a circle with center O and radius 20 centimeters. The points A and B lie on the circle such that angle AOB equals 70 degrees. Find the perimeter of the shaded segment, giving your answer correct to one decimal place. The perimeter of the shaded segment is arc AB plus chord AB. Now, arc AB is found by taking 70, dividing that by 360, and then multiplying that by 2 pi r. Now, 2 pi r represents the circumference of a full circle, and 70 over 360 represents the fraction of the circle that's represented by arc AB, since there are 360 degrees in a full circle. And that equals 24.4346, and so on. Now, triangle OAB is isosceles, with OA equals OB equals 20 centimeters. And that's because OB and OA represent radii of the same circle. So to find the base angles of this isosceles triangle, it's 180 degrees minus 70 degrees in brackets, and then dividing that result by 2, that equals 55 degrees. Now we have 3 known angles, 2 known sides. We can apply the sine rule to find the length of AB. Alternatively, the cosine rule could have been applied since we have 2 known sides and an included angle. So by the sine rule, AB over sine 70 degrees is equal to 20 over sine 55 degrees. Rearranging this equation to make AB the subject, we get AB equals 20 times sine 70 degrees over sine 55 degrees. And that equals 22.9430 and so on. Hence, the perimeter P is equal to 24.4346 plus 22.9430, which equals 47.3776. And rounding this value to one decimal place, we get the perimeter equals 47.4 centimeters. Question 13c, Part 1. Differentiate ln x all squared. The following are the marking guidelines for question 13c, Part 1. For 1 mark, we have attempts to use the chain rule or equivalent merit. And for 2 marks, we have provides correct solution. Ln x all squared is an example of a composite function, hence the chain rule will need to be applied. By the chain rule, d dx of ln x all squared is equal to the derivative of the outer function, which is the squared function, multiplied by the derivative of the inner function, which is the ln x function. So that's equal to 2 ln x multiplied by 1 over x, which is equal to 2 ln x over x. Part 2. Hence, or otherwise, find the indefinite integral of ln x over x dx. From part 1, the derivative of ln x all squared is equal to 2 ln x over x. Hence, the antiderivative or the integral of 2 ln x over x is equal to ln x all squared plus the constant of integration c. Now, 2 ln x over x is double the integrand presented in part 2. So we want the indefinite integral of ln x over x dx. So if we can change this integrand to resemble 2 ln x over x, then finding the antiderivative or the integral is straightforward. And we can do that by multiplying the numerator of this integrand by 2, but then compensating for that on the outside by multiplying the entire integral by half. So the integral of ln x over x dx is equal to half of the integral of 2 ln x over x dx. And using part 1, that's equal to half of ln x all squared plus c. The following is the feedback from the Marking Centre for question 13C. In better responses, students were able to demonstrate an understanding of the laws of logarithmic differentiation and use the chain rule to differentiate correctly. Areas for students to improve include using the product rule or chain rule to differentiate a logarithmic function, using the derivative of logarithms in the previous section to integrate a logarithmic function, and realizing the connection between earlier parts of a question through the use of hence. Question 13e, Part 1. Sketch the graph of y equals the absolute value of x minus 1 for x greater than or equal to negative 4 and less than or equal to 4. The graph of y equals the absolute value of x minus 1 is a V-shape with vertex at 1, 0 and y-intercept at 0, 1. Here is a sketch of the graph drawn to scale. Note the location of the vertex, the y-intercept, and the endpoints, negative 4, 5 and 4, 3. Part 2. Using the sketch from Part 1, or otherwise, solve the absolute value of x minus 1 equals 2x plus 4. We can solve the equation graphically by sketching y equals 2x plus 4 on the graph from Part 1. So here is the graph of y equals 2x plus 4. It's a line with gradient 2 and y-intercept of 4. The x-intercept is negative 2. Note the point of intersection, negative 1, 2. So the x-coordinate of the point of intersection of the graphs of y equals the absolute value of x minus 1 and y equals 2x plus 4 is the solution to the equation, the absolute value of x minus 1 equals 2x plus 4. So from the graph, the solution is x equals negative 1. Now if there is time, we can verify the solution is correct by checking the value of the left-hand side and the right-hand side and showing they are equal. So from the left-hand side of the equation, we have the absolute value of negative 1 minus 1, which equals positive 2, and the right-hand side of the equation is equal to 2 times negative 1 plus 4, which also equals 2. So left-hand side equals right-hand side, therefore x equals negative 1 is the solution. Question 14a. A particle is moving along a straight line. The particle is initially at rest. The acceleration of the particle at time t seconds is given by a equals e to the power of 2t minus 4, where t is greater than or equal to 0. Find an expression in terms of t for the velocity of the particle. The following are the marking guidelines for question 14a. For 1 mark, we have attempts to integrate or equivalent merit, and for 2 marks, we have provides correct solution. Let v represent velocity, a represent acceleration, and t represent time. Hence, the velocity v is equal to the integral of a dt, where a is equal to e to the power of 2t minus 4. Substituting e to the power of 2t minus 4 for a, we have v is equal to the integral of e to the power of 2t minus 4 dt. And that equals half times e to the power of 2t minus 4t plus c. Now the particle is initially at rest, and we can use that to find the constant of integration c. In other words, when t equals 0, v equals 0. And we're going to substitute these two values into this equation to find the value of c. Hence, 0 is equal to half times e to the power of 0 minus 4 times 0 plus c. Hence, c is equal to negative half. Therefore, the velocity v is equal to half times e to the power of 2t minus 4t minus half. The following is the feedback from the Marking Centre for question 14a. Students should show the substitution of t equals 0 into v equals half times e to the power of 2t minus 4t plus c to evaluate c. In better responses, students were able to integrate exponentials accurately and calculate the constant in an exponential equation. And areas for students to improve include understanding that velocity is the integral of acceleration. Question 14b. The derivative of a function y equals f of x is given by f dash of x is equal to 3x squared plus 2x minus 1. Part 1. Find the x values of the two stationary points of y equals f of x and determine the nature of the stationary points. The following are the marking guidelines for question 14b, part 1. For 1 mark, we have finds both x values and determines the nature of one stationary point or equivalent merit. And for 2 marks, we have provides correct solution. Find the stationary points by solving f dash of x equals 0. Now f dash of x represents the first derivative, and in this case it's 3x squared plus 2x minus 1. So we're going to solve the equation 3x squared plus 2x minus 1 equals 0. And this happens to be a non-monic quadratic trinomial. So using the quadratic formula, we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 1 over 2 times 3. And simplifying the right hand side, we get x equals negative 2 plus or minus the square root of 16 over 6. And the square root of 16 is equal to 4. And therefore, x equals negative 1 or 1 over 3. To determine the nature of the stationary points, we can use the second derivative, f double dash of x is equal to 6x plus 2. And we get that by differentiating the first derivative. So f double dash of negative 1 is equal to 6 times negative 1 plus 2, which equals negative 4, which is less than 0. Hence, x equals negative 1 is a local maximum point. And f double dash of 1 over 3 is equal to 6 times 1 over 3 plus 2, which is equal to 4, which is greater than 0. Hence, x equals 1 over 3 is a local minimum point. Part 2. The curve passes through the point 0, 4. Find an expression for f of x. The following are the marking guidelines for question 14b, part 2. For 1 mark, we have finds correct primitive or equivalent merit. And for 2 marks, we have provides correct solution. F of x is the primitive of f dash of x. Hence, f of x is equal to the integral of f dash of x dx. And f dash of x is equal to 3x squared plus 2x minus 1. Therefore, f of x is equal to the integral of 3x squared plus 2x minus 1 dx. And this equals x cubed plus x squared minus x plus the constant of integration c. Now we know that the curve y equals f of x passes through the point 0, 4. And we can use that information to find the value of the constant of integration c. So when x equals 0, y equals 4. And substituting this information into f of x equals x cubed plus x squared minus x plus c, we have 4 is equal to 0 plus 0 minus 0 plus c, hence c equals 4. Therefore, f of x is equal to x cubed plus x squared minus x plus 4. Part 3. Hence sketch the curve, clearly indicating the stationary points. The following are the marking guidelines for question 14b, part 3. For 1 mark, we have provides curve with correct shape or equivalent merit, and for 2 marks, we have provides correct sketch. The first step is to find the location of the stationary points found in part 1. And we can use the function we found in part 2 to find the y-coordinate of the stationary points found in part 1. So f of negative 1 is equal to negative 1 cubed plus negative 1 squared minus negative 1 plus 4, taking care to enclose these values in brackets, and that equals 5. And f of 1 over 3 is equal to 1 over 3 cubed plus 1 over 3 squared minus 1 over 3 plus 4, and that equals 103 over 27, or 3n 22 over 27. Now f of x is a polynomial of degree 3, it's cubic, with a positive leading term, x cubed, and a y-intercept at 0, 4. And that gives us an idea of what shape the curve will take. So putting that all together, this point here, negative 1, 5, represents the local maximum stationary point. This point here, which is 1 over 3, 103 over 27, represents our local minimum stationary point, and this point here represents the y-intercept. Part 4. For what values of x is the curve concave down? The curve is concave down where the second derivative f double dash of x is less than 0, and f double dash of x is equal to 6x plus 2. So we're going to solve the inequality 6x plus 2 less than 0. Subtracting 2 from both sides of the inequality, we get 6x is less than negative 2. Then dividing both sides of the inequality by 6, we get x is less than negative 1 over 3. Hence the curve is concave down for values of x less than negative 1 over 3. The following is the feedback from the Marking Centre for question 14b. Students should factorise a non-monic trinomial to obtain solutions to equation. Show numerical results when testing stationary points using either the first or second derivative. Use a table with labelled rows indicating x, dy dx and slope when using the first derivative test. Integrate and substitute in 0, 4 to calculate the constant. Provide information about the nature of the stationary points, and find and show the coordinates of the stationary points. In better responses, students were able to factorise a non-monic trinomial, show values in their tests for nature of stationary points, correctly calculate the constant, calculate the y-coordinate at x equals negative 1 in y equals x cubed plus x squared minus x plus 4, match their information from B part 1 to their graph in B part 3, and understand that when f double dash of x or the second derivative equals 0, a curve is not concave down. Areas for students to improve include using f dash of x equals 0 to find stationary points, understanding the link between the sign of the second derivative and concavity, understanding what a local maximum stationary point looks like graphically, understanding that f double dash of x less than 0 for concave down, solving linear inequalities accurately, and checking that all parts of a question are attempted. Question 14d. The equation of the tangent to the curve y equals x cubed plus ax squared plus bx plus 4 at the point where x equals 2 is y equals x minus 4. Find the values of a and b. Let f of x equal x cubed plus ax squared plus bx plus 4. We'll call this equation number 1. F dash of x, which is the first derivative of f of x, is equal to 3x squared plus 2ax plus b. We'll call this equation number 2. Now the gradient of the tangent y equals x minus 4 is 1, and this occurs where x equals 2. So this means that f dash of 2 equals 1. So substituting x equals 2 into equation number 2, we have 1 equals 3 times 2 squared plus 2a times 2 plus b. And this equation simplifies to 4a plus b equals negative 11. And we'll call this equation number 3. Also, the tangent y equals x minus 4 touches the curve y equals f of x at x equals 2. So in other words, at the point 2, negative 2. And we get the negative 2 when we substitute 2 for x here. 2 minus 4 equals negative 2. And that gives us the point of intersection of the tangent and the curve. Hence, f of 2 equals negative 2. So from equation number 1, negative 2 equals 2 cubed plus a times 2 squared plus b times 2 plus 4, which simplifies to 4a plus 2b is equal to negative 14. And we'll call this equation number 4. Solving equations 3 and 4 simultaneously, we have 4a plus b equals negative 11, 4a plus 2b equals negative 14. We can use the elimination method here, and we have a equals negative 2 and b equals negative 3. Question 15a. Solve e to the power of 2 ln x equals x plus 6. The first thing to note in the equation is that only positive solutions are possible, and that's because of the term containing ln x on the left-hand side. Ln x, or the natural logarithm of x, is defined for positive values of x only, and that's why x is greater than 0. Now the next step is to change the form of the left-hand side in such a way that we can eliminate the e and the ln, since they are inverse operations. So e to the power of 2 ln x can be written as e to the power of ln of x squared, and that's by application of one of the logarithm laws. So e to the power of 2 ln x equals x plus 6 can be written as e to the power of ln of x squared equals x plus 6. Now e and ln will cancel, so we're left with x squared equals x plus 6, which is a quadratic equation. So rearranging this quadratic equation, so we have 0 on the right hand side, we have x squared minus x minus 6 equals 0. Now we can factorize the left hand side, so we have x minus 3 times x plus 2 equals 0, and we have x equals negative 2 or positive 3 as solutions. But x is greater than 0. Therefore, the only possible solution is x equals 3. Question 15b. The triangle ABC is a right-angled triangle with the right angle at C. The point D is chosen on AB so that CD is perpendicular to AB. The length of AD is P, the length of BD is Q, and the length of CD is H. Show that H equals the square root of PQ. This question may be answered by multiple applications of Pythagoras Theorem. Consider triangle ACB. Now this is a right-angled triangle with AB as the hypotenuse. So AC squared plus CB squared is equal to AB squared. Consider triangle ADC. AC is the hypotenuse of this smaller right-angled triangle, and AC squared is equal to P squared plus H squared. Likewise, triangle DCB, CB is the hypotenuse of this right-angled triangle, so CB squared is equal to Q squared plus H squared. And AB can be expressed in terms of P and Q such that AB squared is equal to P plus Q all squared. So if you go back to equation number 1, I'm going to replace AC squared with P squared plus H squared. I'm going to replace CB squared with Q squared plus H squared, and AB squared with P plus Q all squared. So we end up with this equation here. So P squared plus H squared plus Q squared plus H squared is equal to P plus Q all squared. Now I can combine the like terms on the left hand side and then expand the perfect square on the right hand side, we end up with 2h squared plus p squared plus q squared is equal to p squared plus 2pq plus q squared. Now we'll have some cancellation, so this p squared will cancel with this p squared here, and this q squared will cancel with this q squared here. So we end up with 2h squared is equal to 2pq. Dividing both sides by 2, we have h squared is equal to pq, and therefore h is equal to the square root of pq as required. Question 15c. The entry points R and Q to a national park can be reached via two straight access roads. The access roads meet the national park boundaries at right angles. The corner, P, of the national park is 8 kilometers from R and 1 kilometer from Q. The boundaries of the national park form a right angle at P. A new straight road is to be built joining these roads and passing through P. Points A and B on the access roads are to be chosen to minimize the distance, d kilometers, from A to B along the new road. Let the distance QA be x kilometers. Part 1. Show that d squared equals x plus 8 squared plus 8 over x plus 1 squared. Triangle BRP is similar to triangle PQA, hence corresponding sides are in the same ratio. So BR over 8 is equal to 1 over x. So I've formed an equation here, and we're going to solve for BR by multiplying both sides of the equation by 8. So BR is equal to 8 over x. Now let D equal AB. Now in triangle BCA, notice that I've formed triangle BCA by extending BR a little further and expanding AQ a little further to the left so that they meet up at point C. So we have a large right angle triangle, and we can apply Pythagoras Theorem. So D squared is equal to AC squared plus BC squared. Now AC is the sum of x and 8, so that's x plus 8 all squared. And BC is the sum of 8 over x and 1, so that's going to be 8 over x plus 1 all squared. So D squared is equal to x plus 8 squared plus 8 over x plus 1 squared as required. Part 2. Show that x equals 2 gives the minimum value of d squared. From part 1, we have d squared equals x plus 8 squared plus 8 over x plus 1 squared. So we need to differentiate the right-hand side with respect to x. Let it equal 0. Find the stationary point by solving for x, and then find the nature of that stationary point and show that it's a minimum. But before we do that, we need to express the right-hand side using index notation. So 8 over x needs to be written as 8x to the power of negative 1. So d squared is equal to x plus 8 squared plus 8x to the power of negative 1 plus 1 all squared. Next step is to differentiate the right-hand side with respect to x, and we can use the chain rule to differentiate x plus 8 squared and 8x to the power of negative 1 plus 1 squared. So d dx of capital D squared is equal to 2 times x plus 8 plus 2 times 8x to the power of negative 1 plus 1 multiplied by the derivative of what's inside the brackets, which is negative 8 times x to the power of negative 2. Now to find the stationary point, we're going to do that by letting the right-hand side equal 0. But I'm also going to expand the brackets as well and simplify the right-hand side while we're at it. So we have 2x plus 16 minus 128x to the power of negative 3 minus 16x to the power of negative 2 equals 0. Now these terms have negative indices, and we can see that the smallest one is negative 3. So I'm going to multiply all terms by x cubed, which will turn these negative indices into positive indices. In fact, the negative 128x to the power of negative 3 will turn into a constant term, in fact, and x to the power of negative 2 will just turn into positive x, and we can do that by multiplying everything by x cubed. So we have 2x to the power of 4 plus 16x cubed minus 128 minus 16x equals 0. We can see that all terms, including the constant term, have even coefficients, and the constant term is also even, so we can divide all terms by 2. So we have x to the power of 4 plus 8x cubed minus 8x minus 64 equals 0. And we can factorize the left-hand side by grouping in pairs. So x to the power of 4 plus 8x cubed, we can take out x cubed as a common factor. So we have x cubed multiplied by x plus 8. And for negative 8x minus 64, we can take out negative 8 as a common factor. So I'm going to have minus 8 times x plus 8, and that equals 0. Now x plus 8 is the common factor in these two terms. So the left-hand side can be written as x cubed minus 8 times x plus 8 equals 0. Now note that x needs to be greater than 0 because x represents a distance. So we're only interested in solving x cubed minus 8 equals 0. So solving for that, we can add 8 to both sides. So we have x cubed equals 8, taking the cube root of both sides, we get x equals 2. So next we need to find the nature of that stationary point. And we can do that by testing the value of the derivative on either side of x equals 2. So I'm going to choose x equals 1 and x equals 3 and just find the value of the derivative at that point, or at those 2 points. So f dash of 1, so I'll just go back to the derivative. So using this expression here, so substituting x equals 1 and also x equals 3. But let's just find the value of the derivative at x equals 1. We get negative 126. So that's a negative gradient. F dash of 2 is equal to 0, because that's our stationary point, which we just found. And f dash of 3 is equal to 15.48, and so on, which is a positive gradient. So therefore, the stationary point at x equals 2 is a minimum. Hence, x equals 2 gives the minimum value of d squared. Question 15d. The probability that a person chosen at random has red hair is 0.02. Part 1. 2 people are chosen at random. What is the probability that at least one has red hair? Applying the law of complements, the probability that at least one person chosen has red hair is equal to 1 minus the probability that none chosen have red hair. And that equals 1 minus 0.98 squared, which equals 0.0396. Now this situation can be modelled using a probability tree. 0.98 squared comes from this branch of the probability tree. And that represents the complement of at least one has red hair. So R bar times R bar, that's 0.98 times 0.98, and that's 0.98 squared. And if we subtract that from 1, we get the probability that one of these 3 outcomes could result. So that's at least one person has red hair. Part 2. What is the smallest number of people that can be chosen at random so that the probability that at least one has red hair is greater than 0.4? The probability that at least one person chosen has red hair being greater than 0.4 is equivalent to the probability that no one chosen has red hair being less than 0.6, since they are complementary events. So we're going to solve for n the inequality 0.98 to the power of n less than 0.6. Taking the natural logarithm of both sides, we have ln of 0.98 to the power of n less than ln of 0.6. Now applying one of the logarithm laws to the left-hand side, so the n comes out to the front, we have n times ln of 0.98 less than ln of 0.6. Now note that ln of 0.98 is a negative number. So when we divide both sides of the inequality by ln of 0.98, we need to switch the inequality sign around. So n is greater than ln of 0.6 divided by ln of 0.98. We have n is greater than 25.285 and so on. But n is an integer as that represents the number of people chosen. Hence, the smallest number of people chosen is 26, since 26 is the smallest integer greater than 25.285. Question 16a. A person wins $1 million in a competition and decides to invest this money in an account that earns interest at 6% per annum compounded quarterly. The person decides to withdraw $80,000 from this account at the end of every fourth quarter. Let AN be the amount remaining in the account after the nth withdrawal. Part 1. show that the amount remaining in the account after the withdrawal at the end of the 8th quarter is A2 equals 1 million multiplied by 1.015 to the power of 8 minus 80,000 multiplied by 1 plus 1.015 to the power of 4. The following are the marking guidelines for question 16a, part 1. For 1 mark, we have obtains the expression for A1 or equivalent merit, and for 2 marks, we have provides correct solution. Firstly, the interest rate per quarter is equal to 6% per annum divided by 4, which equals to 1.5% or 0.015 in decimal. Now let capital R equal 1 plus 0.015, which equals to 1.015, and that represents the increase per quarter. Let P equal 1 million, which represents the principal, and let M equals 80,000, which represents the withdrawal at the end of every 4th quarter. Now A1, which represents the amount in the account after the first withdrawal, is equal to the principal multiplied by capital R to the power of 4, since there are 4 quarters of compounding before the withdrawal takes place, minus 1 withdrawal. Now A2, which is the amount remaining in the account after the second withdrawal, is equal to the amount after the first withdrawal, so whatever the amount is in the account after the first withdrawal, multiplied by another 4 lots of compounding, so that's capital R to the power of 4, minus another withdrawal, M. But A1 is equal to P times capital R to the power of 4 minus M. So substituting PR to the power of 4 minus M for A1, we get A2 is equal to PR to the power of 4 minus M in brackets, multiplied by R to the power of 4 minus M. Expanding the brackets, we get A2 is equal to PR to the power of 8 minus MR to the power of 4 minus M. And factorising out negative M, we get A2 is equal to PR to the power of 8 minus M outside of 1 plus R to the power of 4. Now substituting back the values for P, R and M, we get A2 is equal to 1 million multiplied by 1.015 to the power of 8 minus 80,000 multiplied by 1 plus 1.015 to the power of 4 as required. Part 2. For how many years can the full amount of $80,000 be withdrawn? The following are the marking guidelines for question 16a, part 2. For 1 mark, we have obtains an expression for AN, or equivalent merit. For 2 marks, we have correctly sums the series and equates AN to 0, or equivalent merit. And for 3 marks, we have provides correct solution. From part 1, we can generalize a formula for AN, which is the amount remaining in the account after the nth withdrawal. So we have AN is equal to PR to the power of 4n minus M outside of 1 plus R to the power of 4 plus R to the power of 4 squared plus R to the power of 4 cubed plus ... plus R to the power of 4 to the power of n minus 1. Note that we have a geometric progression here, and we can represent this sum using the sum of a GP formula. We have n terms and a common ratio of R to the power of 4. So AN is equal to PR to the power of 4n minus M outside of 1 minus R to the power of 4 to the power of n, which is just R to the power of 4n, over 1 minus R to the power of 4. Next, we solve for n the equation AN equals 0, since after multiple withdrawals of $80,000, eventually the account is going to have 0 in it. So 0 is equal to PR to the power of 4n minus M outside of 1 minus R to the power of 4n over 1 minus R to the power of 4. Next, we're going to make R to the power of 4n the subject of the formula. And we're going to do that firstly by multiplying all terms by the denominator 1 minus R to the power of 4. So we have 0 is equal to 1 minus R to the power of 4 in brackets multiplied by PR to the power of 4n minus m outside of 1 minus r to the power of 4n. And then we're going to expand the brackets. So we have 0 is equal to PR to the power of 4n minus PR to the power of 4 multiplied by r to the power of 4n minus m plus mr to the power of 4n. Next, I'm going to switch a few terms around, and just to clean up this equation a little bit, I'm going to make this negative m into a positive m. So imagine moving that negative m over to the other side. So we have m is equal to PR to the power of 4n minus PR to the power of 4 times r to the power of 4n plus mr to the power of 4n, and then switching both of those sides around. So we're going to have PR to the power of 4n minus PR to the power of 4 times r to the power of 4n plus mr to the power of 4n equals m. Since we're going to make r to the power of 4n the subject, I wanted r to the power of 4n to be on the left-hand side of this equation. And notice that these three terms contain an r to the power of 4n component. And we're going to factorize that out. So we'll have r to the power of 4n outside of p minus pr to the power of 4 plus m is equal to m. Dividing both sides by what's in the brackets here, so p minus pr to the power of 4 plus m, we get r to the power of 4n is equal to m divided by p minus pr to the power of 4 plus m. Next, we're going to take logs of both sides. I'm going to use the natural logarithm, so taking ln of both sides. And by doing that, we can use one of the log laws. This 4n will come out to the front since it's an index. So we're going to have 4n multiplied by ln of r is equal to ln of m divided by p minus pr to the power of 4 plus m. And just notice the use of the brackets there. And then dividing both sides by 4 ln r. So I'm going to leave the n on its own there. So n is equal to ln of m divided by p minus pr to the power of 4 plus m, all enclosed in their respective brackets, divided by 4 ln r. Now we have a value for m, we have a value for p, and we have a value for r. So substituting those values back in and just entering in this expression in your calculator, n is equal to 24.463, so on. And we're going to round that down. So therefore, the full amount of $80,000 can be withdrawn for 24 years. The following is the feedback from the Marking Centre for question 16A. Students should find the amount remaining in the account after the withdrawal at the end of the 4th and 8th quarters by explicitly showing the progression from A1 to A2. Present all working out with clear and sequential steps. Use patterns to generate an expression for AN as a summation of terms, and use the correct value for the common ratio when finding the sum of a geometric progression formula. In better responses, students were able to solve logarithmic equations, and areas for students to improve include understanding the steps required to show a result, and improving accuracy and skill in algebraic manipulation of logarithmic equations. Question 16b. Note that this question has been modified to comply with the current syllabus. A particle moves in a straight line starting at the origin. Its velocity, v meters per second, is given by v equals e to the power of cos t minus 1, where t is in seconds. The diagram shows the graph of the velocity against time. Using 3 applications of the trapezoidal rule, estimate the position of the particle when it first comes to rest. Give your answer correct to 2 decimal places. The following are the modified marking guidelines for question 16b. For 1 mark, we have finds the time at which the particle first comes to rest, or equivalent merit. For 2 marks, we have uses t equals 0, t equals pi over 6, t equals pi over 3, and t equals pi over 2 in the trapezoidal rule, or equivalent merit. And for 3 marks, we have provides correct solution. The particle comes to rest when the velocity v equals 0. Now we need to find the smallest value of time t, where t is greater than 0, when the velocity v equals 0 by solving the equation e to the power of cos t minus 1 equals 0. Adding 1 to both sides of the equation and then taking the natural logarithm of both sides, we have cos t is equal to 0, and therefore t is equal to pi over 2 seconds. Now the distance travelled is equal to the integral from t equals 0 to t equals pi over 2 of e to the power of cos t minus 1 dt. Using the trapezoidal rule with 4 function values, starting from t equals 0 to t equals pi over 2, the values of time are 0, pi over 6, pi over 3, and pi over 2. So we need to make sure that these values of time are evenly spaced. And v of t, or the function value itself, when t equals 0, v of t is equal to this decimal here. We could have kept it in exact form, but I thought for the purpose of this explanation, I've just written out the decimal approximation. V of t, when t is equal to pi over 6, is this decimal. V of pi over 3 is this decimal here. And v of pi over 2 is equal to 0. Now by the trapezoidal rule, the distance travelled is approximately equal to pi over 12, so that's the b minus a on 2, outside of 1.718281828 plus 2 times this function value plus 2 times this function value plus this function value here, which is 0. And that equals, or is approximately equal to 1.51 meters, correct to 2 decimal places. The following is the modified feedback from the Marking Centre for question 16b. Students should quote the reference sheet for the trapezoidal rule and understand the meaning of b minus a over 2. In better responses, students were able to understand the time when the particle comes to rest occurs when v equals 0, and show substitutions into the trapezoidal rule. And areas for students to improve include understanding the difference between radians and degrees when using trigonometric functions, understanding that 4 function values are required for 3 applications of the rule, and simplifying expressions that involve a fractional common difference within a fraction. Question 16c. The diagram shows the region capital R bounded by the curve y equals x to the power of r, where r is greater than or equal to 1, the x-axis, and the tangent to the curve at the point 1, 1. Part 1. Show that the tangent to the curve at 1, 1 meets the x-axis at r minus 1 over r, 0. The following are the marking guidelines for question 16c, part 1. For 1 mark, we have finds the equation of the tangent at 1, 1, or finds the equation of the line through 1, 1 and r minus 1 over r, 0, or equivalent merit. And for 2 marks, we have provides correct solution. To find the equation of the tangent, we need the first derivative of the function y equals x to the power of r. So f dash of x is equal to r times x to the power of r minus 1. To find the gradient of the tangent to the curve y equals x to the power of r at the point 1, 1, we substitute x equals 1 into the gradient function. So f dash of 1 is equal to r, since 1 to the power of r minus 1 is equal to 1, and 1 times r is equal to r. To find the equation of the tangent, we use the point gradient formula, which is y minus y1 is equal to m multiplied by x minus x1, where x1 is equal to 1, y1 is equal to 1, and the gradient m is equal to r. So substituting these values into the point gradient formula, we get y minus 1 is equal to r multiplied by x minus 1. Expanding the brackets and making y the subject of the formula, we get y is equal to xr minus r plus 1. Now the tangent meets the x-axis when y is equal to 0. So when y is equal to 0, substituting that value into the equation of the tangent we just found, we get 0 is equal to xr minus r plus 1. We want to find the value of x such that the y value is equal to 0. So rearranging the formula, we get xr is equal to r minus 1, and then dividing both sides of this equation by r, we get x is equal to r minus 1 over r. Therefore, the tangent meets the x-axis at r minus 1 over r, comma 0 as required. Part 2. Using the result of Part 1 or otherwise, show that the area of the region capital R is r minus 1 over 2r multiplied by r plus 1. The following are the marking guidelines for question 16C, Part 2. For 1 mark, we have recognizes that the area of capital R is the difference of two areas or equivalent merit. And for 2 marks, we have provides correct solution. The area of region capital R is the difference between the area under the curve y equals x to the power of r from x equals 0 to x equals 1 and the right angled triangle formed by the tangent that we found in part 1. Now this right angled triangle has a base of 1 minus r minus 1 over r and a height of 1. So the area of region capital R is equal to the integral from x equals 0 to x equals 1 of x to the power of r dx minus the area of the triangle, which equals x to the power of r plus 1 over r plus 1 from x equals 0 to x equals 1 minus half times 1 minus r minus 1 over r times 1. Now applying the limits of integration, we have 1 over r plus 1 minus half times 1 over r, which equals 1 over r plus 1 minus 1 over 2r. So finding a common denominator, we get 2r over 2r multiplied by r plus 1 minus r plus 1 over 2r multiplied by r plus 1. And combining the numerators, that equals 2r minus r minus 1 over 2r times r plus 1. And that equals r minus 1 over 2r times r plus 1 as required. Part 3. Find the exact value of r for which the area of capital R is a maximum. The following are the marking guidelines for question 16C, Part 3. For 1 mark, we have finds the derivative of the area of capital R, or equivalent merit. For 2 marks, we have finds the value of r at which there is a stationary point, or equivalent merit. And for 3 marks, we have provides correct solution. Let a equal r minus 1 over 2r times r plus 1. Expanding the brackets in the denominator, we get a is equal to r minus 1 over 2r squared plus 2r. By the quotient rule, dA dr is equal to u dash v minus uv dash over v squared, where u is equal to r minus 1, u dash is equal to 1, v is equal to 2r squared plus 2r, and v dash is equal to 4r plus 2. Hence, dA dr is equal to 2r squared plus 2r minus r minus 1 times 4r plus 2 over 2r squared plus 2r all squared. And that equals 2r squared plus 2r minus 4r squared minus 2r minus 2 in brackets over 2r squared plus 2r all squared. Expanding the brackets in the numerator and collecting like terms, that equals negative 2r squared plus 4r plus 2 over 2r squared plus 2r all squared. Now to find any stationary points, we let dA dr equals 0. So we're going to solve the equation negative 2r squared plus 4r plus 2 equals 0. And we can simplify this equation by dividing both sides of the equation by negative 2. So we have r squared minus 2r minus 1 equals 0. So we have a monic quadratic. And we're going to solve this by completing the square. Alternatively, you can use the quadratic formula. And we end up with r is equal to 1 plus or minus the square root of 2. But r is greater than or equal to 0. Hence, a stationary point exists at r equals 1 plus the square root of 2. Now we need to test whether this point represents a local maximum or a local minimum. So testing points on either side of r equals 1 plus the square root of 2, and we're going to choose r equals 2 and r equals 3. When r equals 2, dA dr is equal to 2 over a positive denominator, which is greater than 0. And when r equals 3, dA dr is equal to negative 4 over a positive denominator, which is less than 0. Therefore, maximum value of a occurs when r is equal to 1 plus the square root of 2. The following is the feedback from the Marking Centre for question 16C. Students should find the derivative of an expression with the treatment of the exponent of r, realise that 1 to the power of r minus 1 is equal to 1 to find the equation of the tangent, use subtraction of areas to find the area of the given region, use the quotient rule from the reference sheet and remember to square the denominator, and justify the maximum value by using the simplest method. In better responses, students were able to understand that the tangent meets the x-axis at y equals 0, clearly present all the steps in a show question, solve quadratic equations, and show numerical results when testing for concavity using the first derivative table. And areas for students to improve include carefully examining the given diagram to select the most appropriate and simplest method, considering the marks available for each part to gauge the required amount of working out, using the answer provided in the question as a checking mechanism rather than working backwards, and showing all algebraic manipulations in a show question. Question 16. A bowl is in the shape of a hemisphere with a diameter of 16 centimeters. Now, first thing is I'm going to write the radius as 8 centimeters because the radius is half the diameter. What is the volume of the bowl correct to the nearest cubic centimeter? Now, the reason why I write the radius is because for most calculations, the radius is in fact more important. Now, a hemisphere is half a sphere. So, volume of hemisphere is equal to 4 over 3 times pi r cubed, but we need to divide it by 2 because it's a half sphere. That's what a hemisphere is. Let's substitute in the radius. Okay, it's important to show all you're working out. Pi times the radius cubed, so that's going to be 8 cubed, and we're going to divide that by 2. So 4 over 3 multiplied by pi multiplied by 8 cubed divided by 2, and we get 1072. And its volume, so it's cubic centimeters. Question 17. The diagram shows a triangle with sides of length x centimeters, 11 centimeters, and 13 centimeters, and an angle of 80 degrees. Here's the diagram. Use the cosine rule to calculate the value of x correct to two significant figures. So to get full marks, we need to use the cosine rule, show the working out, of course, and make sure that we round the answer correctly. So, cosine rule. X squared is equal to 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of 80 degrees. So, working out that line there, so that's 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of 80. Okay, and we get 240.3366212. But of course we want the square root of that. Okay, it doesn't seem realistic that we have a side of the triangle that's 11 centimeters, a side that's 13, and another side that's 240. So we need to take the square root. Okay, so x is equal to the square root. Notice that I haven't rounded. We do all the rounding at the very end. Okay, so just to save a bit of time, square root, answer key, equals 15.5027. So what I'm going to do So I'm just going to write down a few extra decimal places, or a few extra significant figures in this case. Okay. But we want 2 significant figures. Okay, so that means first significant figure, second significant figure. We don't go any further. However, the third significant figure will round the second significant figure upwards. Okay, so that's going to equal 16 centimeters, correct to 2 significant figures. Question 18. Andrew, Brandon and Cosmo are the first 3 batters in the school cricket team. In a recent match, Andrew scored 30 runs, Brandon scored 25 runs and Cosmo scored 40 runs. Part A. What is the ratio of Andrew's to Brandon's to Cosmo's runs scored in simplest form? Okay, so we can make sure we underline that. Now, let's have a look at their runs. Andrew scored 30 runs. Brandon scored 25. So make sure we maintain the correct order. Cosmo, last, scored 40 runs. Now, we can see that all of these terms are divisible by 5 because they end in either a 0 or a 5. So what we're going to do is we're going to divide all terms by 5. So 30 divided by 5 is 6. 25 divided by 5 is 5. And 40 divided by 5 is 8. So there's the simplified ratio. Now part B. In this match, the ratio of the total number of runs scored by Andrew, Brandon and Cosmo to the total number of runs scored by the whole team is 19 to 36. So this 19 here is the term that refers to the runs scored by Andrew, Brandon and Cosmo. So for every 19 runs basically scored by these 3 players, the whole team has scored 36 runs. So the first thing we need is the total number of runs scored by Andrew, Brandon and Cosmo. So 30 plus 25 plus 40 is equal to 95 runs. So what we want to do is we want to find an equivalent ratio. So 19 to 36 is equivalent to 95. So this is 95 runs, okay, scored by these 3 players, to X, where X is the total number of runs scored by the whole team. So the way we're going to work this out is by this calculation. 95 divided by 19. Then we're going to multiply it by 36. 95 divided by 19. That tells us how many times 19 goes into 95. And then we're going to multiply that by 36. And we get 180. Therefore, the whole team scored 180 runs. Now, just to make sure that you're on the right track, okay, the ratio 180 to 95, so I'll just do this as a double check, okay. Okay, should equal the ratio 36 to 19. The way we can check that quickly is we enter it in as a fraction. 180 over 95, because fractions and ratios are related. You get 36 to 19. And it works. Question 19. The heights in centimeters of 10 players on a basketball team are as shown. Is the height of the shortest player on the team considered an outlier? Justify your answer with calculations. First thing to note, if you look at the scores, they're listed in ascending order. Second thing is we're dealing with outliers, which means that we want to determine whether 170, the shortest player on the team, is considered an outlier or not. So we need to calculate where the boundary for an outlier would lie. And that is related to the quartiles. Now, the Q3 and Q1. So it's actually going to be related to Q1, the lower quartile. And we need to work out how far below the lower quartile we need to go before a score then is considered an outlier. So let's work out where the quartiles are first. Okay, so there's 10 scores. 1, 2, 3, 4, 5. So the median, which we need to work out first, is between the 5th and 6th scores. So between 192 and 193. So the median is there. Okay, and this is 192.5. Let's have a look at the bottom 5 scores. The median of the bottom 5 scores is 185. So that's our Q1. The median of the upper 5 scores is Q3, which is 194. Now we need to work out the interquartile range, because now we're sort of on our way to calculating this boundary value. Okay, so outside of which a score is then considered an outlier. Okay, so first of all, interquartile range is equal to Q3 minus Q1. Okay, interquartile range is equal to 194 minus 185, and that's equal to 9. Next thing we need to calculate is the lower boundary for an outlier. Okay. Is equal to, it's actually equal to Q1 minus 1.5 multiplied by the interquartile range. Okay, so Q1 is 185 minus 1.5 multiplied by the interquartile range, which is 9. So let's calculate what that lower boundary is. Okay, so 185 minus 1.5 multiplied by 9, and we get 171.5 centimeters. Now, the shortest player is 170 centimeters. Which is less than 171.5 centimeters. Therefore, is considered 170 centimeters is considered an outlier. Question 20. A roulette wheel has the numbers 0, 1, 2, right up to 36, where each of the 37 numbers is equally likely to be spun. If the wheel is spun 18,500 times, calculate the expected frequency of spinning the number 8. So there's 37 numbers, each equally likely. So the probability of spinning an 8 is 1 on 37. Now the number of 8s that we're expected to get, assuming sort of a perfect world, every 37 spins, or in 37 spins, an 8 should turn up once. That's the expected number. So in 18,500 spins, the expected frequency is given by 1 on 37, which is the probability of getting an 8 in one spin, multiplied by the number of spins. 1 on 37 multiplied by 18,500. Which is 500. Question 22. Two right-angled triangles, ABC and ADC, are shown. Calculate the size of angle theta correct to the nearest minute. Now let's analyze this diagram for a moment. We have triangle ADC, that's a right angle triangle. We have a triangle ABC, that's also a right angle triangle. In fact, AC is a common hypotenuse. Now, when you think of right angle triangles, two things should automatically come to mind: Pythagoras Theorem and trigonometry. Now, we want to find angle theta, that's really the prize here. But in order to find angle theta, I need two sides of this triangle ABC, two known sides. I've only got one known side. So I need side AC. BC, at the moment, I've got no chance of finding that. But AC, we can. And we can use triangle ADC, this triangle here, and Pythagoras Theorem, of course, to calculate the length of AC. So let's do that. So by Pythagoras Theorem, AC squared is equal to 2.5 squared plus 6 squared. 2.5 squared plus 6 squared, and we get 42.25. Therefore, AC is equal to the square root of 42.25, and let's express that in decimal. We could either leave it in surd form, or we can express it in decimal. In fact, it's only 6.5. It's not a decimal that sort of goes on forever. Okay, so that's equal to 6.5 centimeters. In fact, so that's this one here. We could add that onto the diagram. Okay. Now, if you turn the page around, right, you can see. Okay, you can see the right angle triangle there, right? And we have our angle theta. This would be our adjacent side. This would be our hypotenuse. Now, according to Sohcahtoa, okay, if you want to use Sohcahtoa, okay, that's your basic right angle trigonometry. This is going to be cos, isn't it? Okay, so cos of theta is equal to adjacent over the hypotenuse. So that's 4.9 over 6.5. Make theta the subject of the formula. So we move the cos over, and it becomes inverse cos. So cos with a -1, a shift cos on your calculator. 4.9 over 6.5. Okay. So shift cos. Okay. 4.9 over 6.5. We get 41.0753, but we want it to the nearest minute. Okay, so we'll press this button here, degrees, minutes, seconds. We get 41 degrees. Okay, you can see that. Yep, 4 minutes, 31.26 seconds. Now we need it rounded to the nearest minute, correct to the nearest minute. So that's going to be 41 degrees. The 4 minutes is going to become 5 minutes because it's 30 seconds and above, rounds the minute up by 1. Question 23. A set of bivariate data is collected by measuring the height and arm span of 7 children. The graph shows a scatter plot of these measurements. Part A. Calculate Pearson's correlation coefficient for the data, correct to 2 decimal places. Part B. Identify the direction and strength of the linear association between height and arm span. In Part C, the equation of the least squares regression line is shown. A child has an arm span of 143 centimeters. Calculate the predicted height for this child using the equation of the least squares regression line. So let's have a look at Part A, which is to calculate Pearson's correlation coefficient for the data. So we're going to turn the calculator on, put it into stat mode. So we'll press mode number 2, stat. And because it's bivariate data, we're going to go to mode 2. Okay, and you'll see the 2 columns X and Y. So let's enter in the data. Okay, so this first point here is 136. for x. Actually, it might be quicker if you just do all the x values first, and then we'll do all the y values. Because every time you press equals, the cursor goes down on the calculator, it doesn't go across. So this one here is 140. Okay, this one is, there's 244s. 144. We have 146. And we have 148. Okay. Now let's scroll back up and let's do the y values. So we have 142. We have another one that's 142. This one's 146. This one's 148. This one's 149. This one's 150. And this one is 152. Press AC. Okay. Now, bring up the statistics menu, Shift 1, and number 5, Reg. And option 3, R. We get 0.98. Now it says identify the direction and strength of the linear association. Now the correlation coefficient is positive and it's very close to 1. So this would be a positive and strong. Linear association. And you can see that actually from the dots on the scatter plot, that if you were to draw a line of best fit, the dots they align fairly close to the line. So you'd expect it to be, it's positive, and you'd expect it to be a strong, wouldn't say probably moderate, but anyways. Part C, the equation of the least squares regression line is shown. So a child has an arm span of 143 centimeters. Calculate the predicted height. So this is just substitution. So height is equal to 0.866 multiplied by arm span, and arm span 143 plus 23.7. 0.866 multiplied by 143 plus 23.7, and we get 147.538. And we can round that to the nearest centimeter. So this will be 148 centimeters to the nearest centimeter. Question 25. A bowl of fruit contains 17 apples, of which 9 are red and 8 are green. Dennis takes 1 apple at random and eats it. Margaret also takes an apple at random and eats it. By drawing a probability tree diagram or otherwise, find the probability that Dennis and Margaret eat apples of the same color. Now, in situations like this, it doesn't matter whether it's 2 people choosing an apple each or 1 person choosing 2 apples. And the question is basically still the same. What is the probability of choosing 2 apples of the same color? And we're going to represent this with a tree diagram. So I'm just going to start it here. Our first choice, we can choose a red or a green. And our second choice, we can again choose red and green, and red and green, independent of what our first choice was. We can still choose a red or a green. However, the probabilities will differ. This is probability without replacement. So these are dependent events, in other words. In other words, your second choice depends on the probability of the second choice depends on what you got in the first choice. Now, originally we have 17 apples in the bowl. So the probabilities are going to be over 17. There are 9 red and there are 8 green. So the probability will be 9 on 17 for red, 8 on 17 for green. Now for the second choice, we've now depleted the bowl by 1 apple. So these are going to be probabilities over 16. So we've chosen 1 red apple already, which means we now have 1 less red apple. So that'll be 8 on 16 for the second red apple, or to choose the second red apple. Green apples though are still the same in terms of the number of apples. We have 8 green apples. 8 plus 8 gives us 16. There's 16 apples in the bowl. Now if we've chosen a green apple, the red apples are still the same number as originally, which is 9. However, we've already chosen a green apple, so instead of having 8 apples, we now have 7. So the two probabilities that we're looking for, the two favorable events that we're looking for, are the red reds or the green green. So they're the two apples that are the same color. So probability of red red is equal to 9 on 17 multiplied by 8 on 16. Probability of green green is equal to 8 on 17 multiplied by 7 on 16. What we do then is we add those two together. So the probability of red red or green green is equal to 9 on 17 multiplied by 8 on 16 plus 8 on 17 multiplied by 7 on 16. And let's do that now. Okay, so 9 on 17 multiplied by 8 on 16 plus 8 on 17 multiplied by 7 on 16. And we get 8 on 17 as the probability. Question 31. A rectangle has width W centimeters. The area of the rectangle A in square centimeters is A equals 2W squared plus 5W. The graph of A equals 2W squared plus 5W is shown. Okay. So part A, explain why in this context the model A equals 2W squared plus 5W only makes sense for the bold section of the graph. And I think if you look on the x-axis here, the W here represents the width of a rectangle. The width makes no sense if the width is a negative number, like -1 centimeters. Okay, so Okay, so anything to that effect, there's 1 mark. Now the area of the rectangle is 18 square centimeters. Calculate the perimeter of this rectangle. So if we're talking about perimeter, and I might just sketch a rectangle here. Okay, there's width and there's the length. So we want the distance around the rectangle. So let's first of all work out the width from the area. Okay, so we're told that the area of this rectangle is 18 square centimeters. So let's use the graph then to work out what the width should be. So using a ruler, okay, so there's 15 square centimeters, 16, 17, 18. Okay, so the y-axis represents the area of the rectangle. Okay, you draw a line across, find out where it intersects with the graph. Okay, if you project downwards, okay, you can see there that the width must be 2. Okay, so using the graph, okay, and I guess just to show you working out, just to make sure that you've shown you working out, okay, you can see that you've used the graph there to project across and then project down. Using the graph, okay, a width of 2 centimeters gives an area of 18 square centimeters. Okay. So that means then that the width is 2. Okay. Now we need to work out the length. Okay. So area is equal to width times length. The area of the rectangle is 18 square centimeters. So 18 is equal to, now the width is 2 multiplied by length. Therefore, length is 9 centimeters. So what's the perimeter? Hence the perimeter is equal to 2 times 9, because you have a 9 up here and you have a 2 here. Right? 2 times 9 plus 2 times 2. Okay, so that's 18 plus 4. Therefore, perimeter equals 22 centimeters. Question 33. The time taken for a car to travel between two towns at a constant speed varies inversely with its speed. It takes 1.5 hours for the car to travel between the two towns at a constant speed of 80 kilometers an hour. So I'm just going to underline the word inversely there. Calculate the distance between the two towns. Now, distance is equal to speed multiplied by time. Now, we can draw one of these to help us. So this is the distance, speed, time triangle. Okay, so distance is equal to speed multiplied by time. Time is equal to distance over speed. Okay, speed is equal to distance over time. So distance is equal to the speed, 80 kilometers an hour, multiplied by time, and the time is 1.5 hours. Multiplying those two numbers together, okay, 80 multiplied by 1.5, and that's 120 kilometers. So the two towns are 120 kilometers apart from each other. Part B. By first plotting 4 points, draw the curve that shows the time taken to travel between the two towns at different constant speeds. Now, we know that the relationship is an inverse one. In other words, if we double the speed, we halve the time taken, and that makes sense, doesn't it? We know at 80 kilometers an hour, okay, it takes 1.5 hours to get from one town to the other. If we halve the speed, so instead of traveling at 80 kilometers an hour, we travel at 40 kilometers an hour. Okay, it's going to take double the time. That makes sense. You slow down, it's going to take longer. It's going to be double 1.5, so that'll be 3 hours. Now, if we halve the speed again, in other words, half of 40, we're going to travel at 20 kilometers an hour. It's going to take double the time again. So instead of 3 hours, it's going to take 6 hours. Now we need one more point. So if we halve 20, you get 10. We don't have enough. The y-axis isn't long enough to put 12 hours to plot the point there. So we need a point in between, because the question clearly states we need to plot 4 points. Now if we go back to the distance, speed, time triangle, we need the formula in terms of time. So time is equal to distance over speed. We know the distance, which is 120 kilometers, over, let's pick a point, let's say 60 kilometers an hour. So 120 kilometers over 60 kilometers an hour equals 2 hours. Okay, so we can plot another point here. So that's 60 kilometers an hour, it's going to take 2 hours. We now have 4 points. We can now draw the curve. So might just this is probably best done with pencil. Okay, something like that, and that'll give you the 3 marks. Question 34. The relationship between British pounds P and Australian dollars D on a particular day is shown in the graph. And in particular, have a look at this point here in the graph. So this point here implies that 7 Australian dollars gives us 4 British pounds. Part A, write the direct variation equation relating British pounds to Australian dollars in the form P equals MD. Leave M as a fraction. So direct variation implies that it starts from the origin at 0, 0. So we only need one point or one known point to work out the gradient M, okay, or the constant of variation if it's the letter K. So P equals MD, pounds, 4 is equal to M times the amount of Australian dollars to give you 4 British pounds, which is 7. Making M the subject of the formula, so rearranging the equation, we have M is equal to 4 divided by 7. 4 over 7. Therefore, the equation is P is equal to 4 over 7 D. Okay. Part B. The relationship between Japanese yen and Australian dollars on the same day is given by the equation y equals 76D. And y is yen, D is Australian dollars, so very similar to the last question. Convert 93,100 Japanese yen to British pounds. So there's 2 steps involved here. First of all, let's convert the Japanese yen to the Australian dollar, because from there we can use part A to convert Australian dollars to British pounds. So let's work this up. So y equals 76D. Okay. Now we have 93,100 Japanese yen. So 93,100 is equal to 76 multiplied by Australian dollars, dividing both sides by 76. So D is equal to 93,100 divided by 76. D equals, okay, so 93,100 divided by 76, and we get 1,225 Australian dollars. Now we need to use part A to convert 1,225 Australian dollars into British pounds. So from part A, okay, P is equal to 4 on 7 times D, which is 1,225. Okay, multiplying that together. Okay, so 4 on 7 multiplied by 1,225, and that gives us 700. Question 36. A small business makes and sells birdhouses. Technology was used to draw straight line graphs to represent the cost of making birdhouses, C, and the revenue from selling birdhouses, R. The x-axis displays the number of birdhouses and the y-axis displays the cost or revenue in dollars. So there's the graph. Part A, how many birdhouses need to be sold to break even? So this is where the revenue equals the cost. So just find where they intersect, project down to the x-axis, and we can see here that 20 birdhouses need to be sold in order to break even. Break even means you're not making a loss or a profit. So the answer is 20. Now part B, by first forming equations for cost and revenue, determine how many birdhouses need to be sold to earn a profit of $1,900. So profit is the difference between revenue and cost, and it's going to be 1,900. So we need to form these 2 equations and then form another equation where R minus C is equal to 1,900. So let's do this first. So let's work out the revenue first, or the equation for revenue. Okay, so that's the solid line. Okay, the y-intercept is 0, so this is an example of direct variation. Okay, so it's just going to be in the form y equals mx. Okay, so the gradient, okay, is equal to rise over run. Okay, so we can just choose a convenient right angle triangle. So we might just choose this one here. The run is 10 and the rise is 400. So if you go up on the y-axis, it goes up in steps of $100. Okay, so that's going to be 400. So the gradient is 40. Okay, y-intercept is 0. Therefore, revenue is equal to 40x. Now let's have a look at the equation that represents the cost. And we're going to do the same thing again. Let's work out the gradient first. Okay. So the cost is the dotted line. Let's find a convenient right angle triangle. We might use this one here. Okay, so you can see where I'm pointing here. So the run is 20. Okay, run is 20. And the rise, 1, 2, 3. Okay, that's $300. Okay. 300 divided by 20 should give us 15. Okay, and the y-intercept is here, 500. Therefore, cost C is equal to 15x, our gradient times x, plus 500. Now what we're going to do is form another equation and solve for x for the profit. Okay, so profit. Okay, R minus C is equal to $1,900. Okay, so the revenue is 40x minus the cost, which is 15x plus 500 is equal to 1,900. Let's now expand the brackets. 40x minus 15x minus 500 is equal to 1,900. Let's now combine the like terms. 40x minus 15x is 25x. And 1,900 plus 500, so this 500 is going to move over. Right? And I'm going to get 1,900 plus 500 should be 2,400. X is equal to 2,400. We're going to divide that by 25. So this 25 is going to be used to divide the 2,400 by 25. So, okay. 2,400 divided by 25, and we get 96. Therefore, need to sell 96. Just be careful anytime you write anything that you must stay above this line and you must stay inside this dotted line here. Question 38. In a particular country, the birth weight of babies is normally distributed with a mean of 3,000 grams. It is known that 95% of these babies have a birth weight between 1,600 grams and 4,400 grams. One of these babies has a birth weight of 3,497 grams. What is the Z-score of this baby's birth weight? So the first thing to note is we have 95% of these babies have a birth weight between 1,600 grams, 4,400 grams. 95% of scores on a normal distribution lie between Z equals -2 and Z equals +2. So that's -2 standard deviations to +2 standard deviations. So 4 standard deviations is equal to 4,400 minus 1,600. Okay. So 4,400 minus 1,600, and we have 2,800. Okay. Therefore, one standard deviation is equal to 2,800 divided by 4, which equals 700. Now that we've found the standard deviation, we can then proceed to find the z-score of this particular baby. So z-score for 3,497, and we're going to use the formula for z-score, which is the raw score 3,497 minus the mean, which is 3,000 grams, over 700. 3,497 minus 3,000 over the standard deviation that we just found, which is 700, and we get 0.71, positive 0.71. Question 39. 2 netball teams, Team A and Team B, each played 15 games in a tournament. For each team, the number of goals scored in each game was recorded. The frequency table shows the data for Team A. The data for Team B was analysed to create the box plot shown. Compare the distributions of the number of goals scored by the 2 teams. Support your answer with the construction of a box plot for the data for Team A. So the first thing we're going to do is generate our 5-number summary. Now, straight away, the minimum score for Team A, I might just write it here on the side. So min score is equal to 19. We need the first quartile, we need the median, we need the third quartile, and we need the max score. And we know what the max score is, it's 28. We're going to use these 5 numbers to draw our box plot for Team A. So first thing we're going to do is put our calculator into stat mode. So mode 2 and then 1 var. Now notice that we need a frequency column. So shift, mode setup, okay, scroll down, STAT number 3, and then frequency on. Right. Now let's enter in the data. So what I'm going to do is I'm going to enter in one column at a time. So 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So they're the scores. Let's enter in now the frequencies associated with those scores. So 19 is 1, 20 is 0, 21 is 1, 22 is 1, 23 is 1, 24 is 3, so let's enter in 3, 25 is 0, 26 is 4, 27 is 3, 28 is 1. So one thing I do just very quickly is just check to make sure that they're entered in okay or accurately. 19, 20, 0, 21, 1, 22, 1, 23, 1, 24, 3, 25, 0, 26 should be 4, 27 should be 3, 28 should be 1, so that looks okay. All right, so we know what our min and max are. Let's generate quartile 1 and median and quartile 3. Shift 1, min max, number 5, number 3, Q1 equals 23. Now, median, shift 1, min max, number 5, median, number 4 there, 26. Now the third quartile, min max, number 5, quartile 3, number 5 there, We've got 27. We now have the data that we need to draw our box plot. So minimum score is 19, so I might just put a little dot there. Okay, quartile 1 is 23, median is 26, okay, quartile 3 is 27, and the maximum score is 28. So, okay, now let's draw it in. So, so we'll draw in the tails. Okay, now we'll draw in the box. Okay, please use a ruler to do this. And our median line. Okay, so a grid's provided, does make it a lot easier to draw in. So there you go. There's our completed box plot for Team A. Let's analyse this quickly. First of all, we can see that the interquartile range, okay, hopefully you can see that, interquartile range for Team A is less than Team B, which means Team A is more consistent. Okay. Next thing to note is that the positioning of the two boxes, including their medians, Team A's box, okay, with their median is lower than the box for Team B. Okay, so that's which implies Team A performed, or we can say that Team A did not perform as well as Team B. Okay, something else to note as well is look at the whisker for Team A. It's clearly much longer than the whisker for Team B. So, and also the positioning of the median as well. So this implies that Team A's, the distribution for the scores of Team A is negatively skewed. Okay, so all right, so the lower tail is much longer than the upper tail for Team A, which implies a negatively skewed distribution. So that means potentially it could be a few players that might not be doing so well. Okay, whereby Team B shows a symmetrical distribution according to their box and whisker plot to the similar length whiskers. And the centrally located median. I've gone slightly over there, but I think that's fairly comprehensive. Question 41. A map is drawn to scale on 1 centimetre grid paper. showing the positions of a supermarket and a cinema. A reservoir is also shown. Part A. It takes 10 minutes to walk in a straight line from the cinema to the supermarket at a constant speed of 3 kilometers per hour. Show that the scale of the map is 1 centimeter equals 100 meters. Now, if you notice, we're working in minutes, go for time, and the scale's in meters. So why don't we convert the speed here, this 3 kilometers per hour, into meters per minute? Okay, so let's do that first. So 3 kilometers per hour is equal to 3,000 meters per 60 minutes. So let's work it out now in meters per minute. Okay. So if we divide both of these terms by 60, okay, 3,000 divided by 60, we end up with 50 meters per minute. Okay, so now it takes 10 minutes to walk in a straight line from cinema to supermarket. So in 10 minutes, distance is equal to 50 meters per minute multiplied by 10, which equals 500 meters. So there are 500 meters between cinema and supermarket. 1, 2, 3, 4, 5 grid squares. Equals 500 meters, 1 grid square is equal to 100 meters, 1 grid square is equal to 1 centimeter. Therefore, the scale is 1 centimeter to 100 meters as required. Okay, so we can add that on here. 1 centimeter is 100 meters. Okay, we're going to need that. So let's have a look at part B. The reservoir is initially empty. During a storm, 20 millimeters of rain falls on the reservoir. With the aid of one application of the trapezoidal rule, estimate the amount of water in the reservoir immediately after the storm. Assume that all rain which falls over the reservoir is stored and give your answer in cubic meters. Let's go back to our reservoir. Okay, so trapezoidal rule, we need the 2 parallel sides of the trapezium. Okay, so what we're doing is we're building a trapezium. Okay, this is 100 meters using our scale. 1, 2, 3. This is 300 meters. Again, using our scale. So that's our scale there. And 1, 2, 3, 4. And the distance between the parallel sides of the trapezium is 400 meters. Okay, so the surface area of the reservoir by the trapezoidal rule is equal to, okay, half multiplied by the distance between the parallel sides. These are the parallel sides basically of the trapezium. If you look at it this way, you can see a trapezium. Okay, so half multiplied by 400 multiplied by the sum of the parallel sides, which is 100 plus 300. Okay, and that's equal to, okay, half multiplied by 400 multiplied by 100 plus 300 is 80,000 square meters. So now during a storm, 20 millimeters of rain falls on the reservoir. Okay, so to estimate the amount of water, first thing we have to do is convert the 20 millimeters into meters. Since the surface area is in meters and we want to answer in cubic meters, that means that the height of water, okay, that's fallen is the meter equivalent of 20 millimeters. So let's do this, convert 20 millimeters into meters. Okay, we'll divide that by 1,000. Okay, if you're having a mental blank, just put in your calculator, right? Don't guess your way through this. Make sure you do not lose a mark here. That's 0.02 meters of water that's fallen. So that's going to be the height of water that's fallen. So the volume of water is equal to 80,000 square meters multiplied by the height of water, that's 20 millimeters, multiplying all that together, and we get 1,600 cubic meters, which is 1,600 kiloliters or 1.6 megaliters. Question 42. The table shows the future values of an annuity of $1 for different interest rates for 4, 5, and 6 years. The contributions are made at the end of each year. Okay, that's very important to note that one. An annuity account is opened and contributions of $2,000 are made at the end of each year for 7 years. For the first 6 years, the interest rate is 4% per annum, compounded annually. For the 7th year, however, the interest rate increases to 5% per annum, compounded annually. So calculate the amount in the account immediately after the 7th contribution is made. Now, just thinking about it, 7 contributions of $2,000, our answer's got to be over $14,000. Okay, so just think about that for a moment. Now, the other thing as well is that for the first 6 years, the interest rate is 4% per annum. So according to our table, we're going to use the last row and the last column, which is this number here, and we're going to multiply that by 2,000 to get the value of our annuity after 6 years, because the 7th year, the interest rate changes to 5% per annum, but it's only 1 year's worth of interest, so we're going to treat that separately and treat it as regular compound interest. Okay, so let's work out the value of the annuity after 6 years. Okay, and that's going to be equal to the contribution, which is $2,000, multiplied by the multiplication or the factor that we're going to multiply by from the table, assuming we chose the correct one, which is going to be 6.633. Okay, and multiplying all that together. Okay, so 2,000 multiplied by 6.633. and we get $13,266. $13,266. Now we need to work out the value of the annuity after the 7th year, but the 7th year the interest rate changes. So value of annuity after 7 years is equal to whatever we had gotten in the first 6 years, so that's going to be 13,266 multiplied by 1 year's worth of compound interest, because it changes to 5% per annum. So it's just going to be 1 plus 5%. And it's 1 year's worth, so it's just to the power of 1, so I'm not going to show that. Okay. So just enter that here. So 13,266 multiplied by 1 plus 5%. And we get $13,929.30. Okay. Now, there's one little bit of detail there that we need to make note of. Go back to the question. It says immediately after the 7th contribution is made. That's only after 6 contributions. Okay, so we need to add the last contribution plus $2,000, and that's going to be equal to $15,929.30. Therefore, value of the annuity after the 7th contribution is $15,929.30.